presentation is the normal distribution, and I'll give you all different possible types of questions that you can get. So once a week, Chris goes for a 5K run. The time he takes in minutes as a normal distribution with a mean of 25.5 and a standard deviation of 3.5. Find the expected number of days during a year, 52 weeks, for which Chris takes less than 25 minutes for his run. Okay, so this is basic. You would have a look, and there's your mean and your standard deviation, or your variance. And then you would, I always put up a normal distribution curve, and then I put what the mean is, and the mean is 25.5. Right, we are looking for where Chris takes 25 minutes or less. So 25 minutes for his run, and we're looking for less than 25 minutes. Okay. So now we want to find a z-score. So we're going to put these values in, and we're going to get minus 0.14, which I'm going to put over there, 0.14. So now I can look in the table. So I've got the table here, and I want to look up 0.14 in the table, and that gives me this value over here, 0.0557. So I chuck that in, and that goes over there. Now I'm actually looking for the probability over here, so I'm going to go 0.5 minus that, and I get the probability. Right, the next question says the probability that Chris's time is greater than k minutes, and they tell us that the probability is 0.166. Find the value of k. So once again, I put my mean in, 25.5, and this time I'm going to put my k value in there. Right, they've given me this probability, so I can fill that in. And now I want to find out what this value is because of my z-score. So I'm going to go 0.5 minus that, and I get 0.334. Now I'm going to look in my table for 0.334, and I find it over there, and I read off my z-score. So it's 0.97 is my z-score. So 0.97, and I'm going to now put that into the calculator, into the formula. So I get z equals x minus my mean over the standard deviation, and I found out what k is. Okay, so those are the two straightforward forwards and then backwards type questions. Okay, this question is a little bit different. Here they are giving us information. They've given us an x value and a probability, and an x value and another probability, and we've got to find the mean and the standard deviation of the distribution. All right, so you have to think a little bit here, because the problem is we don't know our mean. So if we have a look at our mean, we don't know it. All right, and if we don't know our mean, we're not sure where the 59.1 lies on the right of the mean or the left of the mean. So what we have to do is look at the probability. So they've said that if x is greater than 59.1, the probability is very low. All right, so that it's greater than, it means that the probability would have to be on this side, because they're saying that the 59.1 is that probability is very low. Okay, so now I can work with that. So I can go, okay, cool, I've got that. So the same as the previous example, I'm going to go 0.5 minus that, and I'm going to get my probability. I'm going to then find out what my z-score is, and if I look in the table, I'm going to get 2.018, and then I'm going to chuck that into the formula. So now I've got a formula with a sigma and a mu in it. Okay, now I want to look at exactly the same thing. So I'm going to actually just create another one. But this time, they've said 29.2 is the number, but they've said the probability, so x is still greater than, but the probability is 93, almost 93%. So if my mu is there and the probability is 93%, it must be on this side, the 93%. So I know that that 29.2 goes on that side over there. So again, I want to figure out what the value is to look up on my table. So I go 0.93 minus 0.5, and I get 0.4345, and I get a z-score from there. Once I've got a z-score, I chuck it into my formula, and I solve these two simultaneously, and I get sigma and my mean. Okay, this one is an interesting one. I think she's asked it once or twice. The random variable x has a normal distribution. The mean is mu, and they've told us that mu is greater than 0. And the variance is a quarter mu squared. Okay, so this one you could panic in the beginning, but if you follow the formula, you can't go wrong. Okay, so they've asked us to find the probability that x is greater than 1.5 times by mu. So what am I going to do is I'm going to put my mu in. I know that 1.5 mu is bigger than mu, so it has to be over there. And I'm looking for the probability where x is greater than, so I'm looking for this side over here. So now I get a z-score, and I go 1.5 mu minus mu over a half of mu, because my variance, my standard deviation is my variance, square root of my variance, and I get a z-score of 1. If I get a z-score of 1, I can look up in the table and I get that probability over there. So they've asked for the probability that x is greater than, so I'm going to go 0.5 minus 0.3413, and I've got that 0.1587. Okay, the next question found the probability that x is negative, so that might sort of throw you a tiny bit as well. But the probability that x is negative means that you're looking for the probability that x is less than 0. Okay, and they have told us that mu is greater than 0, which means that 0 must be on the left-hand side. So anywhere on the left-hand side, I'm going to put my 0. And now I'm looking for, it just might as well be a number. I'm looking for the number on this side of 0. So I go z equals 0 minus my mu over my standard deviation, and I get my z-score of minus 2. So I know that my z-score is minus 2, and I'm looking for that. So I look again in my table, but this time I get my probability of 0.4772, and I go 0.5 minus that, and I've got my 0.0228. So it's not that difficult, but you'd have to sort of think about it a bit.